Almost there. We got one more after this, and that'll be the last video you have to watch, because after thinking about it, I'm going to do 6.8 in class. I'll talk about that because it's much easier for me to talk shit about it and just go look at other different graphs. So this is going to be the last. You got one more after this. One freaking more after this. So this one and one more. Let's get it. So we want to convert from rectangular equations to polar equations. I left it off on that. So I'm going to continue to use some of your book stuff. And let's look at the first problem here. I have everything you need to know off on the right hand side. So we have x squared plus y squared, and let's say it's equal to 25. Now, more often than not, you just convert x's when you see it. You're like, oh, I'm just going to write it like this. With going from rectangular to polar, just like, dude, every time I see an x, I just change it and go like it's r cosine of theta. And every time I see a y, I just say it's r sine of theta. Typically. But we have this formula that x squared plus y squared is equal to r squared. I'm just going to show you once. So I wouldn't advise going this direction, but I'm just showing you one time. So once you square it up, you get r squared cosine squared plus r squared sine squared is equal to 25. But you all remember algebra, right? You got the same picture, you can factor it out to the front. So you get that r squared times cosine squared of theta plus sine squared of theta is equal to 25. But come on! Sine squared plus cosine squared plus sine squared, that's equal to 1. Therefore, r squared is equal to 25. So you just see that you could just bypass all of this. You didn't need any of it if you just knew x squared plus y squared was equal to r squared. And now the way we write this, the way our equations are going to go, is we think of r. R is what we kind of set it equal to. So we don't want to leave an r squared if we can. We can hit both sides of this equation with a square root, and we can say that r is equal to 5. And there it is. We've converted it. I'm not sure if you know this, but this is the equation of a circle. X squared plus y squared equals a number. The general form of a circle is x squared. Well, this is centered at the origin. It's equal to r squared. Oh, you mean this frickin' formula here that we should have known from other classes in the past? Yeah, that one there. That converts the radius squared. So that's the general form of a circle centered at the origin, but we do have some that will not always be centered at the origin. We'll get into those later. Moving on. Let's try another. Let's keep it mellow on this one. We'll say that y is equal to negative x. Y is equal to negative x. That's a line. That's a line with a slope of -1. That's a slope of negative. So let's see what's going to happen here. Let's just change it all. We're like, all right, y is equal to r cosine of theta, and we got the negative here. We say that x is equal to r sine of theta. Well, this is one of the few times you're allowed to do this. Remember when I told you do not divide out variables? Well, the radius can't be 0. If the radius is freaking 0, it doesn't mean anything anyway. So you can absolutely, in polar, you can divide out these r's. And now you are left with just, what the hell? Cosine of theta equals negative sine of theta? You know what? Let's divide out that cosine and bring it over to the other side. So we end up with negative sine over cosine, or 1 is equal to negative tangent of theta, or tangent of theta is equal to -1. Huh. It's from that formula before that I don't use for following the angle, but tangent of theta is equal to y over x. So if we would have actually messed with this thing at the beginning and just brought the x over, we would have y over x is equal to -1, or tangent of theta is equal to -1. That's kind of a rough one. Let's do another. That didn't have any r in it. No r's. Typically we have an r when we do it. But this one had no r's. Let's do our third. This one will have some r's. Let's do a 3x plus 5y minus 2 is equal to 0. And I ask you the question, what is that? Do you know what the graph looks like? There's no squares on the x's, there's no squares on the y's, so what is it? This is shit you should be able to recognize by now. That's a line. If there's no squares, it's a freaking line. Cool. Well, all we're going to do is zero thought here. Everywhere we see an x, we're going to put in our sine of theta. Everywhere we see a y, we're going to put in our cosine of theta. So this is our, oh shit, that's an x. X's go with cosine. Our cosine theta. I might have said that backwards. My bad. And then our sine of theta. Now our game is you want to solve for r. You want r all by itself. So let's mess around with this. We end up with 3r cosine of theta plus 5r sine of theta. Now I just want to take this 2 and move it over to the other side. So we'll say it's equal to positive 2. And then we play the same game with factoring. There's an r on both of them, so factor your r to the outside. And you're left with 3 cosines of theta plus 5 sines of theta is equal to 2. And again, we're trying to isolate r. So whatever isn't r, we're going to divide it out. So we divide out all this stuff, 3 cosine of theta plus 5 sine of theta. All gets divided out. And we find out that our r is indeed equal to 2 over 3 cosine of theta plus 5 sine of theta. And this is the form we want to leave. Oops. This is the form we want to leave our polar equations in. R is equal to. Remember back in the day we'd say y is equal to, and that's how an equation would look? Now we have r is equal to. And it's okay to have r squared. That one's okay. That's not too big of a deal. Now, shit, let's do one, right? We gotta get crazy. Let's get frickin' weird. Let's get weird. Maybe, I don't know, we'll find out. I've never done this problem before. I'm looking in a textbook going, oh shit, that looks fun. I don't know, maybe this is gonna turn out to be terrible. So we got x squared plus y squared all squared is equal to 9 times x squared minus y squared. Whew, okay. Okay. We're good, we're good. Let's go get it. Let's start doing some conversions. So we see an x squared plus y squared. That shit's r squared. So we're gonna swap that out. We'll call it r squared. And we'll fill this. We got r squared squared. Oops. Is equal to 9 times. But now this is not x squared minus. That's x squared minus y squared. That's not x squared plus y squared. So we're gonna need to maybe do something like this, and then see if we can't play around with all of it. And we'll replace it in with r cosine of theta and r sine of theta. So now we've converted. This shit is now in polar. There's no more x's and y's, there's r's and thetas. We've done half the job. Now the rest of the job is doing algebra and solving for r, or an r squared, or an r to the fourth, or an r to the whatever. Now this is going to be highly challenging. So we end up with r to the fourth, right? That's how that one worked out. And we have 9 times, and let's write it as r squared cosine squared of theta minus r squared sine squared of theta. Would you mind if I factor out what's in common? Let me just factor out what's in common. That's an r squared. Do we take that part out? No, we change this r to the fourth and do that being a different color. So we bring out the r to the outside, right there. And we just leave back behind cosine squared minus sine squared of theta. And if you want to call that cosine of 2 theta, you go right ahead. I think I'm going to probably do that at the end. If you didn't, I don't really mind. Oops, I only pulled out an r. I need to pull out r squared, didn't I? Because that was a square and that was a square. Oops, my bad. There's the r squared. Now it's out. Well, again, we're allowed to with a radius. We can divide it out because it's not going to equal 0. If it equals 0, this is freaking nonsense. It's not true that it equals 0. So we can divide out the r squared and clean stuff up. Because we're trying to get that r all by itself. So we have r squared is equal to 9 times, and I'm going to change this. I'm doing it. That's cosine of 2 theta. Now we could either leave our answer as such, which I'd be fine with this. If you have r squared is equal to stuff and there's no r's, I'm chill with that. R squared equals is okay. Typically we want to have r is equal to though. So maybe we end up with 3 times the square root of cosine of 2 theta. Either or, both acceptable. We're usually okay with an r squared out there. It just depends on a preference. So there we be. There's conversions. Going that way. Now we're going to go the next way on the next one, and we are done with watching these freaking videos. All you got to do is watch me talk shit about graphs in class. I'll be making jokes about butts and stuff. Because some of the graphs look like, well, sorry, they just look like butts. And for some reason I'm 12, and I think that's funny. Alright, see you to the last one.